solved, which is based on the midpoint. The given things are that ABCD is a quadrilateral in which P, Q, R and S. You can see that here it is your P, Q, R and S are the midpoints of the sides AB, BC, CD and DA respectively. Okay. ABCD is a quadrilateral and P, Q, R, S are the midpoints of their sides, and AC is a diagonal. AC is a diagonal. Okay, and we have to prove these three things. SR is parallel to AC and SR is equal to 1 half AC. The second thing we need to prove is PQ is equal to SR, and third thing is PQRS is a parallelogram. We can identify that if the question contains something like midpoints, so it is most probably possible that it is based on the theorem of midpoint, which we call as midpoint theorem. So let us first understand what is the midpoint theorem. The midpoint theorem statement is, it says that the line segment in a triangle, let us understand by drawing a triangle here. It is asking us to think of a triangle. We have drawn triangle, let's call it ABC. Okay, the statement is the line segment in a triangle joining the midpoints of any two sides. Let us take any two sides. Suppose the first side we take AB and second side is AC. So midpoints of any two sides means, suppose midpoint of AB is X and midpoint of AC is Y. So midpoint of any two sides of the triangle is said to be parallel to its third side. So line segment joining the midpoints of any two sides of a triangle is said to be parallel to the third side. If we take AB and AC, any two sides and their midpoints, and the line segment joining them means the line segment joining XY is always parallel to the third side. The third side is here is BC. So if you take XY as the midpoints of these two sides, the line segment which joins the XY will always be parallel to BC. If you take two sides as AB and BC, suppose the midpoint of BC is Z here. So if the line segment joining the midpoints X and Z is always parallel to the third side, means XZ is always be parallel to AC. And if you take the line segment YZ, it will always be parallel to AB. So the line segment joining the two midpoints will always be parallel to the third side of that triangle, and that is called the statement of midpoint theorem. Also, it establishes a relationship between the line segment joining the midpoints and the third side. It says that it is further written in the theorem that the line segment is also half of the length of the third side. The line segment of the midpoints means XY, it is parallel to BC, it is one thing, and the other thing is that XY is always equal to half of BC. Means if BC is 10, XY is 5. If XZ is parallel to AC, it is the one thing that we need to learn from midpoint theorem. The other thing that XZ and AC are related as what? XZ is always equal to half of the AC. If AC is 6, XZ is 3. If AB is 5, YZ is 2.5. Okay. So the midpoint theorem says that the line segment in a joining the midpoints of any two sides of the triangle is said to be the parallel to its third side and is also half of the length of the third side. So we need to have an understanding of this midpoint theorem before attempting this question. Now after learning this, the fundamental theorem of midpoint theorem, Now let us see what this sum has to say. We have already read the question. Let us reread it. ABCD is a quadrilateral, means a closed figure of four sides, and P, Q, R, S are the midpoints respectively of ABCD quadrilateral. Now the first point we need, and AC is a diagonal, it is said, it is given. Now need to be proven that SR is parallel to AC. Where is this SR? This is SR, and it is parallel to AC. It is to be proven by us. So let us take a mini figure out of this whole figure. We are talking about SR and AC. So the figure that contains SR and AC is like this. It is like this. This is S, this is R, this is A, and this is C, and this is D. Okay. So we need to prove that SR is parallel to AC. So you can see that in triangle, which triangle we have taken? We have taken triangle ADC. In triangle ADC, S is the midpoint. S is the midpoint of AD. It is given, already given to us. Okay. And R is the midpoint of DC. It is also given. So as per midpoint theorem, the line segment containing joining the midpoints of any two sides of a triangle, any two sides of the triangle is parallel to the third side. So SR will be parallel to AC. And also the midpoint theorem says that this line segment is always half of the third side, means SR is always equal to 1 half AC. So this way you can see that as per midpoint theorem, we have proven that first is true. The second thing we need to prove is that PQ is equal to SR. PQ is equal to SR means what? PQ is equal to SR. How can we prove that? We'll take the mini figure out of this whole figure. We will now concentrate on this triangle. Which triangle? Let us see that. What we are taking? We are taking this triangle, the lower one. It is A, it is C, and it is B, and here it is your P, here it is your Q, and this is the thing we need to understand separately. Now taking in triangle, which triangle we have taken? We have taken ABC, triangle ABC. Triangle ABC means here P is the midpoint. P is the midpoint of AB. It is given. Okay. And Q is the midpoint of BC. It is also given. So as per midpoint theorem, we can say that PQ is parallel to AC, and also PQ is 1 half of AC as per midpoint theorem. Okay, this is your second statement. So from 1 and 2, you can say that 1 half AC is equal to SR and 1 half AC is equal to PQ. Therefore, SR is equal to PQ. That's why you have to apply midpoint theorem here, because SR is also equal to 1 half AC and PQ is also equal to 1 half AC. So practically SR and PQ are equal. So hence the second point is also proven. Third point is that we need to prove that, show that PQRS is a parallelogram. PQRS is a parallelogram. See, here it is your PQRS. PQRS. So we need to now separate this thing from the whole figure. This is your P, Q, R and S. Okay. Now we need to learn another theorem here. It is the conditional theorem of a quadrilateral to be a parallelogram. How can we say that a quadrilateral is a parallelogram? There is a condition which says that a quadrilateral is a parallelogram. A quadrilateral is a parallelogram if a pair of opposite sides is equal and parallel. Suppose this is a quadrilateral. We have taken that figure out of the whole figure. PQRS is here. This PQRS can be said to be a parallelogram if a pair of opposite sides. Now, what are the pairs of opposite sides here? The one pair is PQ and SR. The other pair is SP and RQ, or PS and QR. Okay. So if we are able to say that any one pair of opposite sides, either this pair or this pair, if any one pair of opposite sides is equal and parallel, then we can say that this PQRS is a parallelogram. Now we have already proven that PQ and SR are equal. So PQ and SR are equal. So one thing is satisfied, that the pair of opposite sides is equal. Also, if you look at the whole figure, we have proven that SR is parallel to AC and PQ is also parallel to AC. Here you have proven that. See, SR is parallel to AC and PQ is also parallel to AC. So if SR is parallel to AC and PQ is also parallel to AC, then we can say that if SR is parallel to AC and PQ is also parallel to AC. Here comes the third theorem. The two line segments parallel to a common third line segment are always parallel to each other. So the common third line segment is AC. You can say that here it is your AC. SR is parallel to AC. PQ is parallel to AC. Then two line segments parallel to a third common line segment are always parallel to each other as well. So if SR is parallel to AC and PQ is parallel to AC, it is but obvious that SR is parallel to PQ. Now you have two things. SR is equal to PQ and SR is parallel to PQ. And for a quadrilateral to be a parallel, you need any one pair of opposite sides equal and parallel. So SR and PQ are opposite sides. They are equal also. They are parallel also. Therefore, we can say that PQRS is a parallelogram. Okay. So this is how you can prove that all these three conditions. You can prove these three conditions based upon the midpoint theorem, this theorem, and a theorem that which says that any two lines parallel to a third common line segment is always parallel to each other. Okay. If you have any other doubt regarding this, you can always write your remarks in the comment section. I will help you to resolve your queries. And if you want any other question to be solved, please also post that question also. Thank you.